Welcome to this Nexa tutorial. Today we will talk about revision sequences. This video is mainly aimed at administrators, but it also contains useful insights for our regular users. At first we will briefly review the role of the revision sequences. Later, we will see how to use the revision sequence editor to build custom ones. Most of the information of this video can also be found in the Nexa Administrator Guide. You can download it at www.essigplm.com. Our files, like CAD parts, documents, and drawings, can be modified during their lifetime. For this reason, when an object is first injected into Nexa, it is automatically assigned a revision sequence that depends on its class. This sequence will allow us to understand the evolution of the object, quickly trace older versions, and understand when major changes have happened. Please remember that Nexa keeps all the old versions of a file. The users can access any of these versions with the help of the revision sequence. Nexa automatically updates the revision sequence only at the time of a check-in. We will see later that the revision sequence value can also be changed manually by the users in certain cases. Please note that it is possible to change the attributes of an object by right-clicking on it, selecting Alter, and modifying any of the blue attributes. These changes, however, do not trigger automatic upgrades of the revision sequence. Only a check-in procedure gives rise to an automatic upgrade of the revision sequence. The structure of a revision sequence should allow us to spot at a glance those versions that have been used for production. To obtain this result, revision sequences usually comprise of two different levels, one referring to normal development changes, and one referring to changes after a release phase. Let's see a schematic example of how revision sequences work. A CAD assembly is first injected into Nexa, and it is assigned the revision sequence value, AV11. Later, the engineer checks it out, modifies it, and checks it back in. With a checksum, Nexa verifies that the file is not identical to the one checked out and automatically updates its sequence value to AV22. The management decides that this part is mature and releases it for production. At this point, Nexa fixes the revision. No more values beginning with A will be allowed. After a while, new changes need to be undertaken and the object is checked out, modified, and checked back in. Nexa prompts its revision sequence value to BV13 since it is the first step of a new revision level. A different engineer needs to work on the right suspension. After completing his work, checks in the file. Nexa automatically brings its revision sequence value to BV24. Finally, a CAD user checks out the assembly, completes the left suspension, and checks in the file. Its revision sequence has now become BV35. In total, there are 5 different versions of this CAD assembly, starting from when it was first injected into Nexa to its most recent updates. We see their number in parentheses. It is easy to spot that AV22 was a major step in the evolution of this part since the following modifications have a different revision level, B. Let's summarize the parts of a revision sequence. One is dedicated to the major changes in the life of an object, like when it is released. We will call this revision. In the above example, we had 2 levels of revision, A and B. A second part of a sequence gives us information regarding the evolution of the file within a given revision. In the above example, revision A underwent 2 of these steps, while revision B underwent 3 of these steps. It is also possible to show the total number of changes of an object. We call this version. In total, we had 5 versions of the same CAD part. Oftentimes, the revision sequences can contain fixed text characters, like acronyms, that help the users to understand at a glance the meaning of its symbols. In the example, there was the letter V and the parentheses. Nexa automatically adds a trailing asterisk to the revision sequences of all non-latest versions of a file. Let's see in detail how to build custom revision sequences with the Revision Sequence Editor. We log into Nexa with an administrator account and select Administration, Revision Sequences. If we right-click on one of the revision sequences in the central pane, we are prompted a few intuitive options: Add, Copy, Delete, Save, and Discard. Add allows us to build a new sequence from scratch. If we want to build a new sequence based on the selected one, we should click on Copy. This prompts a window where we need to enter the name for the new sequence and, optionally, its description. Once saved, we can start to modify the newly created sequence. In general, the properties of the selected revision sequence are shown in the right-hand pane. All we have to do is to modify them and save. For example, we select a custom revision sequence prepared for this video called Product Center Version. The revision format allows us to define the structure of the sequence. Here we can enter the variables for the revision, the changes within a revision, the versions and fixed strings of characters. 3 keywords can be used in the revision format field. The correct syntax for the keywords requires them to be encased in braces and preceded by a $sign. The keywords are rev, that refers to the current revision value. The revision implies a major change triggered by the object being released. We will see later that there is a lot of freedom in defining the revision values. They can include characters, letters, or even combinations of them. N refers to the changes within each revision. It is an incremental integer updated each time the file is checked in at a fixed revision value. After any revision change, N is reset to 1. The keyword N can be repeated more than once. For example, if we enter NNN, Nexa will write 3-digit numbers, padding them with zeros on the left if its quantity contains less than 3 digits. If an item is at the 13th step, a padding 0 will be placed to the left, obtaining 0, 1, 3. Var. This keyword refers to the current version value. It returns an integer that increases by 1 every time that a file is checked into Nexa. At a variance in respect to n, this variable never goes back to 1. The version allows us to see the total number of steps undertaken by the item during its evolution. Let's see an example of evolution in the revision sequence. We had previously injected a PNG image in Nexa following the current revision sequence. Its current revision sequence value is DV11. We check it out. We modify it by cropping it. And we check it back in. As we can see, the revision sequence value has changed to DV22. Now we release the image. It means that we want to use the image in production. Any further change should trigger a revision change. To do so, we right-click on the file, select Release, and Approve. Please notice that this does not trigger any revision change. The reason is that the file has not changed. We will see the effect of the release only for the following modifications. We check out the file, modify and check it back in. As expected, due to the release, the new revision sequence value is EV13. The revision has passed from D to E. V1 tells us that this is the first version of revision E. In parentheses, we see that this is the 3rd version of the file stored in Nexa. Although the revision sequence is updated automatically by Nexa at any check-in, the administrator can grant the users the possibility to change manually its value. To do that, let's have a look at 3 checkboxes under Allow Revision Override. They are Add, Check-in, and Alter. If one of them is checked, it means that during the corresponding operation, when we access the window with the metadata of the file, we will have the possibility to manually change the value of the revision sequence to the object under consideration. It is possible to see live the effects of our changes. One important property that you should remember is that when you modify the structure of a revision sequence, these modifications propagate to all the objects in Nexa that already use that revision sequence. At present, the Alter box is unchecked. We go to the desktop area in Nexa where we keep our most commonly used files, and we right-click on the image. We select Alter, and we notice that the revision attribute, whose value is E, is not modifiable. It's in gray. Let's see what happens when we check the Alter box in the revision sequence editor and save. We go back to the same image file in the desktop area. We right-click on it and select Alter. This opens the window with all the attributes of the file. As we can see, the revision attribute is blue and it has a drop-down menu. Please notice that in this case, it's not allowed to select any revision value prior to the current one, like, for example, A. We select the revision value F. To allow the users to select revision values that come before the current one, we need to go back to the revision sequence editor. We see that there are 3 other boxes under Allow Previously Unused Revisions. We check Alter. Now it is possible to use earlier values, provided that they have not yet been used. We save and we go to the desktop area. We right-click on the New CAD PNG and then Alter. We select the drop-down menu of the revision sequence and we see that the revision A, B, and C are now available. We select A. After we save, we check all of its versions in the right-hand pane. We see that the revision sequence values do not follow the alphabetical order since we modified them manually. The previous revision was D, but since the A value had not yet been used, we were able to assign it to the present version of the file. It is also possible to use legacy revision values. This typically happens when we are dealing with files related to old systems or sometimes when the origin of these files is from another company that has been incorporated by ours. We will see in a minute how to build a sequence that contains legacy values. If we check yes, these values will be selectable. Otherwise, the users won't have access to them. Under selected classes, there are those classes that use the current revision sequence. When building a new revision sequence, this field is empty. To add any class to this revision sequence, all we have to do is press the plus button. Select the desired class and press OK. Likewise, we can remove a class by selecting it, pressing on the X button, and confirming our choice. If we build new revision sequences and we add a class already served by the other revision sequences, the newest one will become the default for any new object. The older files, instead, will keep on using the revision sequences they were using before. Below Selected Classes, there is the Revision Sequence Values box. Here we can see all the possible revision values for this sequence. For new sequences, this box is empty. It is possible to load a revision sequence stored in a text file, or we can enter manually the single elements by pressing Insert Value. When we press Insert Value, Nexa opens a new window where we can insert any alphanumeric value we want, spaces included. For example, we enter the text Test Revision 1. We press Add Revision. We see that it is now part of the list of revisions. We can change the order of the entries by selecting one of them and pressing Move Up or Move Down. We can remove an entry by selecting it, pressing Delete Value, and confirming the choice. Now we select the revision value A and we press Insert Value. It is also possible to add minor revisions to a specific revision value. Minor revisions are not triggered automatically by Nexa after a release, but we will be able to use them manually, for example, when doing an alter. If you hover the mouse over the question mark, a window shows you many shortcuts that allow you to quickly generate many sequence values. In this case, I enter A-D, lowercase, and I press Add as Minor Revision. Notice that now there's a triangle beside A. I click on it to expand the minor revisions. As stated before, the minor revisions can only be triggered manually via an alter operation of a file. If we select one of the values and we press Toggle Legacy, this value will be outside of the normal revision sequence, accessible only if we allow legacy values by clicking on the box we saw a few minutes ago. Notice that it is possible to save the revision sequence at any point in time during its creation. However, the sequence is usable only when there is at least one revision value in it. Summary. We have seen how to work with revision sequences. They allow us to quickly understand the evolution of a file in Nexa. They also enable quick access to any of the older versions of a file since they are safely stored in the vault. A revision sequence usually contains 3 parts. The revision refers to changes of the release status. Within each revision value, there can be upgrades of the file that are tracked with the keyword N. Nexa also keeps track of the total number of versions of a file with the keyword ver. The revision sequence can change in different situations. Nexa automatically updates the value of the sequence when a modified file is checked in. If the file has been released after a check-in, Nexa changes its revision to the next value and N is reset to 1. If granted by an administrator, a user can manually update the revision value during any of the following 3 phases: add, check-in, and alter. Please remember that modifying the metadata of a file during an alter operation does not trigger any automatic revision sequence update from Nexa. Finally, we have seen how to use the revision sequence editor to easily build custom revision sequences that can incorporate legacy values and minor revisions. Subscribe to our channel and turn on the notifications so that you won't miss any Nexa updates. Thank you for watching.